Hi everybody! Today we're going to divide using area models and number bonds. Some people might ask, why do we want to use this strategy? I'd rather just use the standard algorithm. And in the end, that's really the goal. The end goal is to divide just the old-fashioned way using standard algorithm. However, the area model and number bond can help us learn how to manipulate numbers to make them easier to divide, and in real life that can become super handy. So along with this video you will see the area model and the number bond, and I will also show a strategy to help us if we're not sure of our division facts. If we don't know them really well yet, we can always write our multiples on the side of our paper, and that will help us. Let's get started. Let's try solving a division problem by drawing the area model. In our directions, we're going to try and find the action words and do our cubes just like any other problem. It says, look at the area model. What division problem did Alfonso solve? So if we look at this area model that they drew for us, the numbers on the inside will always be our dividend, and they just broke it up into numbers that are easily divisible by an even number. So if we add these numbers together, 40 plus 32, and put those two boxes together into one whole box, we will get 72. So our dividend is 72. Now, our divisor is always the number on the outside, even in our area model. So we know my divisor is 4. So the problem Alfonso is trying to solve is 72 divided by 4. We can also write it another way. 72 divided by 4. Either way is correct. B says, show a number bond to represent Alfonso's area model. Start with the total and then show how the total is split into two parts. Below the two parts, represent the total length using the distributive property and then solve. So if we look at this part B, there's a lot going on here. We have 1, 2, 3, 4 steps in this one problem. So let's chunk it and do piece by piece. First it says show a number bond, which is already here. These 3 circles connected together. There is our number bond. And so we don't have to worry about that one. Show how the total is split into two parts. So our total is what we found before, the 72. And Alfonso split it into two parts, which would be these two boxes in the area model, 40 and 32. Now 40 and 32 are very special numbers because our divisor is 4. And so Alfonso picked two numbers that are multiples of 4. So we know that they will divide evenly. And one of the ways we can find these numbers is writing our 4s out on the side of our paper. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. 40 and 32 are on our list. Okay, so now all we have to do is divide 40 and 32 by 4. So there's our first step. We have 40 divided by 4 and 32 divided by 4. 40 divided by 4 is 10, and I can use my list to help me find that. If I count by 4s, I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 4s to make 40. And if I do 32, 1, 2, 3, 4, 5, 6, 7, 8 4s make 32, so 32 divided by 4 is 8. Now if I need to add the 10 and the 8 together, I get 18. So I showed how the total is split into two parts, and then I represented the total length in the distributive property, and I solved the problem to get 18. Now, as always, we can check our answer to make sure we got the right one by using multiplication. 18 times 4. 8 times 4 is 32. 4 times 1 is 4, plus 3 is 7, and I'm back with my dividend, so it checks. Let's try one that we have to draw the area model and number bond ourselves. This problem says, solve 45 divided by 3 using an area model. Draw a number bond and use the distributive property to solve for the unknown length. So if I look at this problem, I have 1, 2, 3, 4, 5 steps to this problem because I have 5 action words. I circled the numbers as our cubes tells us to do, so I know I'm doing 45 divided by 3. So I need to count by 3s because I'm looking for 2 numbers that I can split my 45 into that will be a little bit easier to divide in my head than 45 and 3. So let's try it. Let's do 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, so I'm going to look through my list and find 2 numbers that equal 45 if I put them together, but they're easy to divide by 3. So just looking through this list, I know that 30 is easy because 30 divided by 3 would be 10. And if I think that I need 45 to be my total, and I'm going to use 30, what's left is 15. And 15 is also on my list, and that's easy. 15 divided by 3 is 5. So I'm ready for my area model. I'm going to draw my area model, split it into 2 boxes just like we saw before. My divisor always goes on the outside, and I'm going to put my 2 new numbers that I highlighted on the side inside my boxes. So now I'm looking for a missing number to go on top, and as our area formula tells us, length times width equals area. So I'm looking for something that's, I can think in my head, 3 times something equals 30, 3 times something equals 15. So even if I don't know the division facts, I can flip it around and do multiplication instead. So I know 3 times 10 is 30, and 3 times 5 is 15. And so now I have my partial products. 10 plus 15 equals, oops, I made a mistake there. 10 plus 5 equals 15. Jumped ahead a little bit. So let's review our steps. I solved 45 divided by 3 using an area model. I have not drawn my number bond yet, so that's what I will do next. I'm going to draw my circles, just like I saw in the previous problem, and fill in the numbers. I don't have any more math to do. I've already done all the hard work. Now I'm just filling in what I know. My original number was 45, and I split it into 30 and 15. 30 divided by 3 was 10. 15 divided by 3 equals 5. And 10 plus 5 equals 15. So either way, we get a correct answer.